Okay, let's begin. Okay, so today we're going to be looking at complex numbers, and this is the Algebra 2 slash Precalc class. And I'm your instructor, Shreyas.S. Okay, so if you have any questions, you can message, I guess. I'll try to look at them. Okay, so first, we're going to look at the numbers. So there's positive integers, which are 1, comma 2, comma 3, all they're positive integers, which are like 1, 2, 3, 4, 5, 6, 7, 8. They don't have any decimal, essentially. The decimal is like 0.00000. And then there's negative integers, which are like -1, -2, -3, -4. And then 0 is considered neither a positive or negative integer. Then rational numbers are any number that can be written as a fraction. So 1 over 2 is a rational number. 5 is also a rational number because you can write 5 as 5 over 1. And then numbers like root 2, so the square root of 2, is considered not rational because if you assume it was rational, then you could write root 2 as p over q. Then p is equal to root 2q because you can just cross multiply, find that out. Square both sides, you're going to get p squared is equal to 2q squared. So p must be even and q must also be even. That's not possible as p over q is already in lowest terms. Because if you have an even on the numerator and an even on the denominator, you can clearly factor out a 2 and cancel it. So root 2 is not rational, or it's said to be irrational. That's the term for not rational numbers. Okay, imaginary numbers. So if you wanted to find x such that x squared is equal to -4, you would assume there would be no solutions. But to fix that, Euler introduced I, which is the square root of -1. So x would be equal to 2i in this case, or it could be -2i. So now that I was created, he had introduced a whole new set of numbers, which would be regarded as imaginary numbers. The other group of numbers are called real numbers, which we are more familiar with, like 2, 3, 2.3, stuff like that. Those are the real numbers. There are more important things. There's some important things to know about I. One thing is that I to the n repeats every 4. So what I mean by that is I to the 0 is equal to 1, I to the 1 is equal to I to the 2 is equal to -1, I to the 3 is equal to I to the 4 is equal to 1. Make sure you guys can see this because I'll just explain them. So I to the power anything is equal to 1. And I to the power 0 is always equal to 1 because anything to the power 0 is equal to 1. I to the 1 is just going to be itself, so I. I squared is going to be equal to -1 because this I is equal to the square root of -1. I cubed is just going to be -1 times I, so negative I. And then I to the 4th is going to be -I times I, which is -1 times -1, which is 1. So you notice that the power, the value of I to the n repeats every 4. So the reason this is useful is because if you want to find out I to the power 1007, you can just divide this by 4 and find the remainder. So the remainder is going to be 3. And since it repeats every 4, it's just going to be equal to I to the 3, which is -I. So that's kind of why that's useful. Okay, complex numbers. So a complex number is written as a plus bi, where a is the real part and bi is the imaginary part. Arithmetic for these numbers applies the same to these numbers as the same they do to regular expressions. So what I mean is if you want to find out 1 plus x plus 2 plus 2x, you would do 1 plus 2 plus x plus 2x, which would be 3 plus 3x. So 7 plus 2i plus 4 minus 3i will be 7 plus 4 plus 2i minus 3i, which is 11 minus I. Okay, and something really important to note is a plus bi times a minus bi is a squared plus b squared. You might have seen a similar expression to this for a squared minus b squared, but there's no I. So a squared minus b squared is a plus b times a minus b. The conjugate of a complex number, a plus b, for example, is a minus bi. So what you do is you just essentially reverse the sign of the bi term. The conjugate can be denoted with a line over the complex number. So if I was asking you what's the conjugate of a plus bi, I could just put a line over a plus bi, and you should assume that's a minus bi. if I put a line over the complex number. Okay, multiplication. So multiplication of complex numbers is also pretty simple. So a plus bi times c plus di is equal to ac minus bd plus adi plus bci. Notice how I use the distributed property to show this, because if you do a times c plus a times di, you get the stuff here. So then, and remember that I squared is equal to -1. So that's pretty important here, because if you don't know I squared is equal to -1 and you assume it's 1, then you're just going to put plus bd. But since I squared is -1, you put minus bd. Okay, here's two examples using conjugates. So you're asked find a such that -3 plus ai times -3 minus ai is a real number. So we talked about how a complex number times its conjugate is also a real number, because we said like a plus bi times a minus bi is a squared plus b squared, which is clearly real. So a must be equal to a, because -3 plus 8i times -3 minus 8i is a real number. Here's another example. Write 3 minus I over -2 plus 5i as a single complex number. So you can multiply the denominator by its conjugate. So you're going to do -2 plus 5i times -2 minus 5i, and you're going to get a squared plus b squared, which is just 4 plus 25, or 29. So the fraction becomes 3 minus I times -2 minus 5i, because whatever you multiply the denominator, you must multiply the numerator, and it becomes -11 minus 13 on the numerator, and the denominator is 29. So we use this to simplify this complex number. We used it to write the complex number as a single one, essentially. Okay, graphing complex numbers. So graphing complex numbers is similar to graphing regular ordered pairs. So the y-axis is the imaginary axis, and the x-axis is the real axis, and the distance from the complex number to 0, 0 is the absolute value. Okay, so the angle the complex number forms at the positive x-axis is called the angle, or the argument of the complex number. So if I wanted to like find the angle for 3 plus 4i, for example, you could plot it, and then you could take arc10. So since the x-axis is the real part, so you put 3 here and then 4i, so 4i goes up there. So that's kind of how you would express a complex number. So for example, another example is like 2 plus 2i. You'd write it as 2 on the x-axis and then 2i on the y-axis. So it'd be 2 comma 2. So if you wanted to find out the angle, you just take arc10. Since you want to find out this angle right here, you take the y over the x, because that's kind of how you do tan. So it'd just be arc10 4/3 for 3 plus 4i. And if you want to find the distance from the origin for 3 plus 4i, since you graphed it as 3 comma 4, 3 comma 4i essentially, the distance is going to be 3 squared plus 4 squared, and the square root of that, which will be 5. Notice how the distance cannot be negative. So when you take the square root of 25, don't write -5. You just write 5. Okay, I continued. So if you want to find the distance between two complex numbers, you can use similar techniques as if we're finding the distance between 2 points in a Cartesian plane. So the distance between the complex numbers 3 plus 4i and 2 plus 2i will be this. You just take the difference of the x coordinates, right? So the x coordinates are 3 and 2, so 1 squared, and then the difference between the y coordinates, which will be 4 and 2, so that's 2 squared. So the distance between the two complex numbers will be the square root of 2 squared plus 1 squared, which is the square root of 5. So do you guys understand the stuff so far? Okay, good. So we kind of already talked about this. The sum of two squares, x squared, like x and y, x squared plus y squared, is x minus iy times x plus iy. And x squared minus y squared is x minus y into x plus y. Okay. This is when complex numbers apply more to math competitions, these type stuff. So you look at, there's three main forms of complex numbers. So there's the rectangular form, which is like what we talked about, a plus bi, a minus bi, well, b is negative. And then there's polar form, which is r times cosine theta plus I sine theta, where theta is the angle formed at the positive x-axis, or the argument of the complex number. And then there's the exponential form, which is r times e to the I theta. And notice that e to the I theta is just cosine theta plus I sine theta. And r is the absolute value of the complex number, or the distance from the complex number to the origin. And then, wait, yeah, so cosine theta plus I sine theta can also be written as cis theta if you want to write it in a more compact form, because no one really wants to keep on writing cosine theta plus I sine theta over and over. Just write cis theta. Okay. Multiplying and dividing complex numbers. So this is the reason that that form of complex numbers is more useful. So if you have two complex numbers, z times e to the ia and y times e to the ib, and if you want to multiply them, you write it as z times y times e to the ib times e to the ia. Do you get this so far? Yeah. So now if you know your exponents, if you do e to the a times e to the b or any exponent like that, you're essentially adding the powers, right? So this also becomes z times y times e to the power I times a plus b. So you kind of understand that, right? Okay. So the reason that I showed that right now is because if you want to take the product of two complex numbers, say like 8 times cosine 45 plus I sine 45 and 5 times cosine 45 plus I sine 45, this product will be 8 times 5 times cosine 45 plus 45, because we talked about how you add essentially the angles. So cosine 45 plus 45 plus I sine 45 plus 45. So you can easily find that cosine 90, which is just 0, and then sine 90, which is 1. You can simplify that. And if you want to divide them, then you do 8z over y, so 8 over 5 times cosine 45 minus 45 plus I sine 45 minus 45. So it'll just be 0, cosine 0 plus I sine 0, which is just 1 here. So you get that, right? Okay, I'll just talk about what sine, cosine, and tangent are, as someone made a suggestion. So I'll just make a new slide. Wait. Okay. So there's three main functions we're gonna talk about. So there's sine theta, then there's cosine theta, and then there's tan theta. So sine theta, the kind of the main thing I would think about that. wait, the main thing I would say about sine theta is, one second. Yeah. So if you have a right triangle, right? So let's just look at this angle right here. This angle right here. Wait. So you have this angle right here. So sine theta is said to be opposite over hypotenuse. Okay, so for example, if I want to find out what is sine of this angle, I would take opposite, so the length of this divided by the hypotenuse length. So that's sine theta. Then you have cosine theta, which is adjacent over hypotenuse. So if I want to find cosine of this angle, I would take this length over the hypotenuse length. And then you have tan theta, which is going to be opposite over adjacent. So opposite over adjacent, adjacent, right? So it's going to be, if you want to find tan of this, it's going to be this over this. It's also said to be sine theta over cosine theta. And another thing you want to know is that sine squared theta, sine squared theta theta is equal to 1. So that's the important stuff you should know. So do you get it? Do you get this? Okay, so let's move on now. Oh, yeah. So the reason that we looked at those different forms is for these type questions. It becomes really useful to know those forms. So if you want to find out what is the 1 plus root 3i to the power 3, so you can write this in terms of cis theta as a cosine theta plus I sine theta. That's pretty crucial to solving this problem. So first you want to find out r, which is just going to be the absolute value of the complex number. And that's just going to be the square root of 1 squared plus root 3 squared, which is equal to 2. And then theta is just going to be arctan root 3, which will be 60 degrees. I wouldn't necessarily do arctan for this case. I would just like draw it out and then quickly see it's a 30, 60, 90 triangle. So you know the angle is 60 and r is equal to 2. So our complex number is 2 cis theta, or 2 times cosine 60 plus I sine 60. So when you cube a number, you essentially multiply the number by itself 3 times. Because we talked about how if you express it as e to the I theta and you multiply 3 times, you're essentially adding the exponents. So if you multiply this 3 times, you're going to get 8, right, times cosine 60 plus 60 plus 60 plus I sine 60 plus 60 plus 60, which is equal to negative 8. because cosine 180 is -1, and then that's 0. Okay, roots of unity. So roots of unity are the roots such that x to the n is equal to 1. Notice that if x is 6 cis theta, right? R, let's just say r times cis theta, but r is going to be 1 clearly. So then x to the n is equal to cis n theta, right? Because we're multiplying it n times, so the theta adds up n times. So cis n theta is equal to 1. This means cosine n theta is equal to 1. And this happens when theta is equal to 0 over n, 360 over n, 720 over n, and so on. And note that we will go up until we get the nth root. So eventually we're going to get to some point where the roots are essentially the same as 0 over n. It's just going to be like 360 or something. And cis 360 is equal to cis 0. So it seems like this example, it seems like the application for this is actually not that useful, but there's actually a lot of um oh wait, where did we get 0 over n, 0 over 360 over n? Because cosine n theta is equal to 1, right? You know cosine 0 is equal to 1, cosine 360 is equal to 1, cosine 720 is equal to 1. So theta is equal to 0 over n, 360 over n, 720 over n. Do you get it? Okay, so yeah, so as I was talking about, so there's another application of the roots of unity, and it's called the roots of unity filter. I don't know, some of you guys might have heard of it, but it's basically an algebra topic, so that's kind of why knowing the roots of unity is really helpful. But it's like an HMMT or something topic, so you don't need to worry about that too much. But just know that it'll pop up later, the roots of unity filter. Okay, so here's an example. Find the roots of x to the 3 is equal to 1. So this is clearly just a roots of unity question, because that's the general form of a question. X to the power n is equal to 1. So our answers are going to be cis 0 by 3, cis 360 by 3, cis 720 by 3, as we talked about, because cosine n theta should be equal to 1. And you won't take cis 1080 by 3, because that's essentially the same thing as cis 0. Because, yeah, cis 360 is equal to cis 0. Because the period of cosine and sine is 2 pi, or it means they repeat every 2 pi. Cis 0 is equal to 1, cis 120 is equal to negative half plus root 3 by 2i, and cis 240 is equal to half minus root 3 by 2i. Do you guys understand? Okay, so I'm gonna present 5 problems. I'll give you guys like 1 minute, 2 minutes to work on each of them, and then I'll discuss the solution. So here's the first problem. I'll give you guys 2 minutes. I'm starting. No, I'm going. Yeah, yeah. I have to. Okay, I'm gonna discuss it now. Many of you guys already got the answer. I'll just wait. Okay. Okay, so first, right, I'll just go through the long way. Even though I already told you it's when it's cis 0 over n, 360 over n, I'll just go through the long way. So we assume our answer is in the form cosine, so let's just say cis theta. Because every number can be expressed as cis theta, essentially. All the real numbers as well. And same with the complex numbers. So if we assume our roots are cis theta, right? If we do x to the power 6, we're going to get cis 6 theta. And this should be equal to this should be equal to 1. So cis 6 theta is equal to 1. This means cosine 6 theta plus I sine 6 theta is equal to 1, right? And since there's no imaginary number here, so I sine 6 theta has to be equal to 0. So that means sine 6 theta is equal to 0 and cosine 6 theta is equal to 1. So you just want to find out when is cosine 6 theta equal to 1. So now it's pretty easy. It's just when theta is equal to 0, right? 60, 120, 1, 180, 240, and 300. So those are your answers. So when theta is equal to, sorry, your roots are cis 0, cis 60, cis 120, 180, 240, 300. So those are your roots. Okay, number 2. Evaluate 4 times root 3 by 2 plus I by 2 to the power 4. Okay, let's begin. So again, many of you guys probably got this answer as well. So we can express this as r cis theta. So in this case, r cis theta times 4, sorry, times 4, and then that whole thing to the power 4. So now you just do 4 to the power 4, which is easy, 256 times r to the power n cis. Do you guys understand this? Do you guys understand this so far though? Like what I wrote? Okay, so someone asked why is it r to the power n? So so basically we talked about how any complex number can be expressed as cosine theta plus I sine theta. So in this case, if we express it as cis theta, which is the same thing as cosine theta plus I sine theta, times 4, because we have a 4 right here, and we're taking that to the power 4. So if you expand this, you're going to get r to the power 4. Oh wait, I should have wrote 4 here. Yeah, that's my fault. My bad. 4. 256 times r to the 4 times cis 4 theta. Now does it make more sense? Okay, so now if you do, now you want to express root 3 by 2 plus I by 2 as a complex number. So clearly r is going to be equal to 1 because the square root of 3 by 2 squared plus half squared is equal to the square root of 1, which is 1. So 1 times cosine of the argument plus I sine argument. And the argument will be 30. Right? Because the reason it's true is if you take like a right triangle, right? You should just memorize the 30, 60, 90 triangle, honestly, because it pops up a lot on these type problems. In a 30, 60, 90 triangle, if the angle is 30, then the angle adjacent to it will be root 3 by 2. So just memorize that. I don't know how else to say. Or you could do like, arc tan of half over root 3 by 2, or arctan root 3 by 3. But it's better to just memorize that. So you're doing 1 times cis theta to the power 4. So r to the power 4 is going to be equal to 1, right? So 1 to the power 4 times cis 120. This is going to be equal to cosine, this is going to be negative half plus root 3 by 2. Just know your trig here, because, okay, there's some identities I should have talked about. Wait, let's just go back here. So here's some more important identities. So cosine negative theta is equal to cosine theta. Sine negative theta is equal to negative sine theta. Then cosine 180 minus theta is equal to negative cosine theta. And then sine 180 minus theta is equal to sine theta. And then finally, cosine 90 minus theta is equal to sine theta. Those are your main identities to know. So we can use that. Yeah, I just wrote down those trig tricks because I'm talking about those in this question right here. Kind of how cis 120, right? Cis 120 is equal to cosine 120 plus I sine 120, right? So if you use cosine 180 minus theta, you know that's negative cosine theta. So that's just going to be negative cosine 60, and which is negative half. So that's kind of how I got that. And then sine 120 is going to be sine 60, which is root 3 by 2 I. And then just multiply this by 256, and that will be negative 128 plus 128 root 3I. Okay, do you guys get this? Or do you need me to go over it again? Do you guys get this? Okay. Okay. I'll give you guys 2 minutes again to work on this one. Yeah? Yeah, yeah. Okay, Matt, lower the volume. Okay, let's begin. Okay, so cosine theta plus I sine theta to the power 3 is a real number. So cosine 3 theta is a real number, right? Real number. Because, again, this is just cis theta, and cis theta to the power 3 is cis 3 theta. So since you want this to be a real number, that means sine 3 theta should be equal to 0. Because if sine 3 theta is anything but 0, then you're going to have an I term. So you want sine 3 theta to equal 0. So now you want to look at what theta, like what sine thetas are there such that it's equal to 0. And sine theta is equal to 0 at 0, 180, 360, and so on. So every multiple essentially of 180. So that means theta is equal to 0 works, theta is equal to 60 works, theta is equal to 120 works, 180, 240, 300, and 360. So those are your answers. Alright, do you guys get this? How I got 0, comma 60, comma 120 as my answers? Do you guys get that? Okay, no. Okay, buttercream. What do you not get? Like, tell me something I can go over it, because the class ends at 2. Buttercream? Wait. Okay, how did I get cosine 3 theta? So I talked about cosine theta plus I sine theta is equal to cis theta, right? Cis theta. And cis theta is equal to e to the power I theta. Because I talked about this right here. Wait. Yeah, right here. E to the I theta is equal to cosine theta plus I sine theta. So if I do cis theta to the power 3, right? To the power 3, this will be equal to e to the power I. Let's just say theta is a. Because writing out theta just makes it look weird. E to the IA, right? To the power 3. 3. Right? Do you get that so far? Oh yeah, you can also prove the cosine theta plus I sine theta to the power n is cosine n theta plus sine n theta, I sine n theta, using the sine a plus b stuff, but I won't do that. So yeah, so you get that, right? So e to the I theta to the power 3 is e to the I theta times e to the I theta times e to the I theta. So if you do 2 to the power 2 times 2 to the power 2 times 2 to the power 2, what do you get? Yeah, exactly. You get 2 to the power 2 plus 2 plus 2 because you're adding the exponents. So essentially, e to the IA is equal to e to the power 3ai. You get that, right? So that's why cis a to the power 3 is going to be equal to cis 3a. Yeah, so now that you know that, then you can get that this is equal to cosine 3 theta plus I sine 3 theta. And then after that, you just need to know trig. Just what is sine 3 theta equal to 0? And you just get 0, 60, 128, 180, 240, 300, 600. Okay. Okay. I'll give you guys 2 minutes to work on this one. Hmm. Yeah. No, hold on. Okay, let's begin this one. I'm just gonna put a 30, 60, 90 triangle in here because some people probably don't know about it. So I'm just gonna 30, 60. Okay. Okay, yeah. This one should be good. Okay, so this is your 30, 60, 90 triangle. The side adjacent to the 60 degrees, if that's A, the side adjacent to the 30 degrees is root 3A, and your hypotenuse is going to be 2A. Do you guys get that? Ma, I'm trying to teach. Ma. Okay, so using that, you want to find the angle such that the complex. Wait. Alright, this should say number here. That just makes it sound weird. Okay, find the angle that the complex number. Okay, this should not be there. Okay, 1/2 plus root 3I over 2, half plus root 3I by 2 forms with the positive x-axis. So if I graph this, right, you're going to be putting half as your x-coordinate essentially, and your y-coordinate's going to be root 3 by 2. You get that, right? Yeah, so since you have that, you're essentially, this is going to be your x-coordinate, like your x length, and this is going to be your y length. Notice that half, right, and root 3 by 2, root 3 by 2 divided by half is root 3. So this is clearly a 30, 60, 90 triangle. And if our angle is 60, then the x length will be a, and our y length is going to be root 3a, which is true. So our angle is 60. That's kind of how I think about it. Okay, and one last problem. This is an Amy problem, so have fun with this. It's not too hard though. Okay, I'll give you guys 2 minutes to work on it.
Strawberry.
God.
पोती नहीं है आज हेयर कट करा देगा हेयर कट कराएगा आज
Wait. There.
Who is saying algebra to class?
It is.
कौन-कौन है दिखा तो कौन-कौन कितना बच्चा है नंबर ऑफ किड्स तो दिखा
12.
विराट कोहली विराट कोहली अपना नाम रखे हुए हैं पूछा are you really विराट कोहली are you fake विराट
Hey man, I'm gonna go talk now.
ये सब काम नहीं करना लिख फिनिश करो तुम काम सब
Okay, are you guys done? You're done, okay? Okay, I'll give you guys then 1 more minute. This is Amy. Yeah. Okay, I'm gonna discuss it now. So the question says there's a complex number z with imaginary part 164 and a positive integer n such that, okay, this should be in parentheses. I mentioned this already. Such that z over z plus n is equal to 4i. Find n. This was on Amy 1 from 2009, and it was number 2. Let z be equal to a plus bi, right? Then clearly z is also, wait, and since the imaginary part of z is 164, then bi must be 164i. This means b is equal to 164. So you want to find n such that a plus 164i over a plus 164i plus n is equal to 4i. You guys get this so far, right? Okay. Okay, good. So now we can cross multiply. So you're gonna get, okay, so you're, the technique here is to group a and a plus n and then as one group, and the other group should be 164i. The reason you do this is because 164i times 4i is a real number. So if you write it like kind of like this, 4i times a plus n, and then plus 4i times 164i. And this is equal to a plus 164i. You get this as well so far. Okay, so you get that, right? Okay. So now the thing to notice here is that since a is a real number and n is a positive integer, clearly 4i times a plus n is going to be an imaginary number. Okay, this should say I. Wait, I. And then 4i times 164i, right? Since I squared is equal to negative 1, it's going to be equal to 4 times 164 times negative 1, which will be equal to 656. Negative 656. Okay, this makes sense, right? Yeah, okay. So negative 656 is going to be equal to a, where did I write it? Is it going to be equal to a plus one, sorry, is going to be equal to a because a is a real number, right? And we know that a plus 164i is going to be equal to all this. So a has to be negative 656. So we have a is equal to negative 656. So now that a is equal to negative 656, you can plug that into this equation, and you're going to get 4i times negative 656 plus n should be equal to 164i. Because this is the imaginary part of this expression, and the imaginary part of this expression should be equal to this expression. So 4i times negative 656 plus n should be equal to 164i. So if you divide 4i from both sides, you're going to get 41 is equal to negative 656 plus n. So n is equal to 697. Wait, n is... So we're done. Okay, thank you for attending the class. I hope you guys understood everything. If you have any questions, just tell me right now. Okay, you guys all good? Okay, bye. Oh yeah, also the next class is going to be on Tuesday for me, and then Amol might be teaching later, which is this guy, Shri Bolapali, in this. He's going to be teaching the next class also for himself. Okay, bye.